So now we would like to open up the floor for questions. So please feel free to ask any of the speakers, either regarding their particular talk or particular in general questions. You can ask them what they had for lunch. No. Oh yeah, there's a question there. Gabriel, do you? Or Jessica will be there.
Hello, I have a question for the first speakers. How do you define hands-on programming? Is it just having a theoretical approach to programming and doing it on a computer, or doing it with a hands-on tool?
If it's green, it's on.
Okay. We have a fairly pragmatic definition, if you call it, not even a definition. It's when you work with your hands on the keyboard, basically. That is hands-on. And so students work in pair, and one in the pair is sitting with their hands still and discussing. So they are solving a problem together, and one is at the keyboard, and one is discussing the problem. So they are helping each other to solve the problem.
There was a question a few rows in front, I think.
Really the same question.
Wait.
Yeah, thanks. Was the colleague, the control group, the one that didn't use the keyboard? Okay, thank you.
That was a quick question. More questions? Oh yeah, Linnea.
I have also a question for the first speakers. You said that there was no gender differences. Was that only in the knowledge or also in the attitudes toward the subject?
In this pre-study, we only looked at the knowledge because the aim of the pre-study was to look at the knowledge. No examining, so we do a good knowledge test, and so that's what in the results. Yes.
But we will, in the full data gathering, we will look at attitudes and perception of oneself's abilities and so on. Because we know that these things can, contribute to if you learn or not. So.
I think Jody also has a question. Wait.
So maybe this is a question for the second and third talks. The second talk talked about technology education, and then the schools where they were using technology in the different subjects. So I'd like to hear your opinions on integrating the digital competency part into other subjects rather than just technology, just like in social sciences in elementary school or in school, you would learn about how to write letters to people. We had these diagrams. This is how marketing works, and so because these are all subjects that are interdisciplinary, sort of, if you see digital competency as a single subject.
Yeah, I would like to say that ICT or educational technologies are essential to school and has been over the last 100 years or 300 years or anything. I mean, the digital tools are, of course, revolutionary in its ways also, but we have had ICT waves for many decades with new tools coming up. So I think all subjects can benefit from it in different ways.
But if I had to ask a follow-up question, because what you're saying, the tools keep on changing.
Yeah.
Isn't that an argument against teaching anything about tools and more focusing on the kind of concepts and kind of why they work and how they work rather than the tools themselves?
Yes, yeah. I understood the question as how to use ICT tools across the school subjects. But and from a technology education perspective, we of course talk about the function of the different technologies we have in use, but we have a lot of technologies. one of the slides I didn't show was about how different countries structure their technology education. Some do it in contexts. Some put it like digital technologies, food technologies, architecture, and things like that. So while other school subjects like the Swedish have perspectives on technology, so where digital technology can be one example.
Well, my opinion is we need an interdisciplinary perspective because the subjects, like I said in my talk, are expanding. So for instance, in the Swedish subject we're discussing now, the aesthetics is interesting. How you communicate visually, for instance, in pictures and images, or how you can understand that communication and have the critical view on that. So that is a quite crucial question, what the subjects actually are today. What are we going to teach in Swedish, in mathematics and technology and so on? What are the key competencies we need to develop?
So I have a question regarding that. I think you brought this up with teacher education, and I know there's a lot of discussions around teacher education. So I'm curious, because in the third talk it was really about this kind of the digital competence in the teaching. Digital competence in the teaching practice. So then it's more for the teacher perspective, while Claes and others is more the digital competence of the students or the pupils in a subject. So, sometimes we have two perspectives, both digital competence for the teacher in order to develop their practice, but we also have being able to teach digital competence to the students. So I'm curious, do you think that the teacher education has to change? And in that case, how should it adapt to address these challenges?
Absolutely, and the teacher education needs to have input from how the society is developing in the network and the communication. What I try to demonstrate is the challenges in the teaching practice that the students don't have a clue about today because we don't teach them about that. And it's not that it's not about just giving the best practice examples. It is very crucial to understand the context, and when I implement the technology in the classroom, what I'm going to achieve as a teacher. Is it this functional perspective I want to achieve, or is it other perspective I want to achieve for my students? So absolutely we need to develop also the teacher education.
Claes, what,
Agreed.
you have anything? What?
You agree? Agreed.
Because you both work at teacher education, and we as kind of external observers sometimes feel that it takes a bit too much time for teacher education to catch up. How do you respond to that kind of accusation?
Agreed on that. Agreed on that. That's not.
You agree?
No, it's. I've been in the board for the ICT studio at Linköping University, and there's slow responses from the teacher programs, and I think we could really develop something there. We need to, and with the pre-service trainings and things like that also, and the communication with the schools where they do their practice.
Yeah, I have a similar history. I work with teacher education for some years now, and there is no easy way to implement the digital aspects in the education. I think it would be really nice with a national policy as well there, that these competencies are needed. And we also need a competence development for teacher educators. So they need to develop competencies and understand society today.
Yes. But we
now there's
but
a
we
lot of
also
hands
need more
raised there.
research to communicate this.
So I think
that's-
Örebro University wants to have some say here.
Yeah.
Well, David Perkins and his friend Salomon wrote a seminal article in 1989 trying to explain why there were so little transfer of general competences from programming and coding. And they had an idea of two ways of getting into this general competence. And one was the low route. And that's the hands-on you're talking about. But they said 50 hours of programming or 100 hours doesn't help. It takes years to get these kind of competences that Jeanette was talking about earlier. And the problem is, are the teachers ready to teach the high road, the principles, the ideas about computational thinking? Is it possible, or is it just a hopeful dream we are talking about?
I guess that's an empirical question. Yes.
Is it on?
Any comments on that?
You go ahead on.
Then I have a comment to do. It's possible to get this digital competence into academic and the teacher programs. We just done that at Örebro. We have a field of persons within the teacher programs, educational, the didactics, the computer scientists, working together to make a really good teacher education programs where the teacher students get the skills needed for the future of Swedish primary and secondary school and preschool. So it's possible. Don't give up. It's possible. I promise.
Nothing is impossible. Maybe. Yeah.
More questions? Okay. So actually, I had another question, and that I think again it's kind of towards the class, because I mean you said this, that much of the learning well, you didn't really say, but I mean one interpretation of your image there was that much of the learning, especially when it comes to digital competences, actually happens outside school. And in some sense, that's also another of these challenges for school, how to deal with the fact that this is not something that you only do within the walls of your classroom, but it's something that goes on throughout the day, throughout your life, so to speak. So how could schools kind of address this, or how can they take advantage of it? I mean, regarding this previous comment, I mean, yeah, it doesn't. Just a few hours might not be sufficient. Could it be used also as a way forward, so to speak?
Yes, I would say that it's a way forward, but one of my points of messages was that technology is all around us, so is the digital technology, and the examples when we teach about concepts like Lars were talking about, or Jody talked about algorithms, and in physics we talk about energy, in social sciences we talk about big concepts like democracy or power or things like that, and we fill them successively with some kind of understanding over the years. And so when I say the pupils meet the digital world outside of school in the free time, the school can be the part where we not compensate only for those who doesn't meet the digital world out there, but also give them new perspectives on an understanding of the digital world, where they hack and meet and make and do and dojo and all the stuff they do. We give them new perspective on it and talk about so they can make comparisons between the technology of the digital technologies and other kind of technologies they meet, other kind of technological systems, production systems, and digital systems. So I mean that could be one of the roles for the technology subject within the 200 hours we have. That the digital world, we can pick examples from there as well as from the rest of the made world.
It's not really my field of expertise, but I would see kind of two parts to this sort of ICT business. One is the competency, which you can, as you say, you can acquire it on your own digital competency. But there I would see the role of school maybe to handle the parts that maybe not come so naturally. Of course, people will consume different media and learn different things on their own, but when you get into the school setting, I feel that focusing on things like, for instance, sourcing and, you know, these types of critical thinking, especially with regards to information and news and these types of things, that these types of sort of academic skills is what the school should focus on. Or in the second setting is the more sort of programming or, you know, higher education setting. That's the more technical. So if you're interested in this stuff and want to be an engineer, then you need to know this. But the primary focus for school should be sort of how to interact with the systems that people already are familiar with.
Thank you. Now, Arnold, have a question or a comment. Up, with your thumb. No, they're uppe there.
Right, now I've got the right colour of green. So I'm going to put a proposition to you all. Maybe simulation is the big game changer that computing brings to the table. Because what we can do is we can now, in nearly any subject context, ask a question, establish a model, and explore alternative futures. We can do it in cultural geography, we can do it in languages, we can do it in biology, we can do it in chemistry. It gives us a made world power that we've never had before to explore alternative futures that don't yet exist. Maybe that's what we should be focusing on. Do you have a comment?
No. I think it's brilliant.
Well, I would say that that's what distinguishes us from the animals, right? We can think into the future and sort of think, if I do this, will I be in jail or will I be happy? So you're constantly running the simulation in your head. Of course, you can then do these sort of more, of course, computationally hard questions.
Says the neuroscientist.
Yes.
Yeah, well, social issues is, I would say, far more hard to sort of model, but we seem to be okay at it at least.
Well, I think simulation is one of the things. I mean, you can use computers to visualize your own competencies. They are becoming more obvious when you use computers, and then we have to teach teachers how to use the technology for that purpose, for instance. So there are different aspects of the same question.
I would also, I'm not sure I did say it on the final slide, that the school, and I think the school, not only the technology subject, but the school as a whole, is would need the help from the computational sciences community, not only with how do we do with programming and simulation and things like that, but also with the ethical questions, the values, the international things, the effects on society and environment, things that are very close to your competition, your competence and profession. So I would like you to address that question in respect to the school to help us out there. I think you have a lot of good stuff for us there also, not only with 27 hours of Java discussion or of Python, what it was. Yeah.
I think we've reached the conclusion that programming was not the key here.
No, so
I fully agree. I mean, as Örebro said over there, I think it's really about the collaborative effort between, the teacher training programs, educational sciences, and the computer science and so on. I mean, if either of those would do it on their own, the result would not be as good as if they were to, or if we are to collaborate.
Well, so, I want to add something here. Being a teacher in ethics and IT, in Malmö University before I was a doctoral student, I will take the ball and throw it back at the industry and say that if you have the demands on teachers learning a lot, and using technology in the classroom, you should develop technology or software that are more plastic, that are more changeable, so the teacher can use a little bit of programming or digital competence to change things, to put in the context they are at, and maybe developing together with teachers. And that would solve both the problem, better software and also getting the teachers involved in digital competencies. So, so not just throwing the ball to the teachers, being like passively adapt, or it's also the software who have to be adaptable to learning and theories and the practice, I think.
Maybe there are some companies involved in developing that kind of software that might be thinking about some comment to that.
I would like to ask a question here.
Oh yeah, sure.
Because we are talking about collaboration between different experts, but here we have an expert in neuroscience.
Yes.
So how can neuroscience actually, some people question this, how can neuroscience contribute to our understanding of teaching and learning? I asked him in advance if you wanted to.
No, well, of course, I would say that one of the challenges when dealing with technology, and especially what to teach and how, is of course why you do it in the first place. And that's kind of hard because technology is evolving very fast, and the demands of future sort of work, for instance, it's almost impossible to sort of guess beforehand what skills will be needed and by who. I think it's fairly clear that digital competency is something that people need more and more, and it will probably get worse in the future. So if you're computer illiterate today, you have huge problems. Tomorrow it will be worse. But one thing that's not likely to change very fast, of course, is human nature. So I would say the more we know about what types of information is hard to learn, what's easy to learn, what's fun to learn, this type of information is always going to be useful, I think.
So actually, I had a question to you regarding your particular project, because you're basically going to study fMRI imaging of the brain. So I'm curious, kind of, how many hours of training or teaching would be required to even be able to detect a change in the brain?
Minutes.
Minutes.
I don't really, it's hard to answer, but what we are interested in this project particularly is more or less if we can split, since this is dealing with programming, what type of information is actually being learned, sort of. Can we split programming into different aspects? Like, I mean, it obviously involves text reading and maybe some math, something, so, because programming is often thought of as sort of one complex thing. So it might be the case that by sort of identifying subcomponents that make up program learning, you can sort of identify what might be good to focus on.
I realized that I misunderstood, because what I understand that you're basically looking at the brain while it's doing the learning,
yes, so the subjects
not
are basically
studying the brain afterwards and see whether it actually changed for these kind of long-term
No, we're not
effects.
doing a fMRI study of the long-term effects, but what we're essentially doing is sort of the day after this learning session, we're going to basically have them perform similar tasks as they would do normally on paper, but while they're in the scanner, so we can see which areas they're using and how much.
How do you program while in a scanner?
Well, not really. We show them code and they answer simple yes or no questions, because you can have buttons, but of course you can't move and you can't really type. You can type, but it's easier to just answer.
We have been working a lot with the relationship between the questions in the questionnaire or in the knowledge test and the questions in the fMRI camera, so you could map them in some way. So, but it's constrained, of course, the fMRI camera setting. So, yeah.
So the hypothesis, I would say, is that maybe if you learn something by using your hands, it's stored differently in the brain than if you have learned it by talking and discussing. Yeah. And from programming, I would say that everyone knows that you learn better if you do it by hand. So we want to. So this is kind of one piece of the puzzle to understand what happens when you actually do like this.
More questions?
I have one.
Oh, yes, please.
It kind of follows up of your question, and since we're talking about the brain and all processes, you often hear saying that, oh, kids nowadays, their brain is differently wired because they use all these, they are glued to their cell phone and so on and so on. So is it really, I guess they really mean that their brain works differently? But is that really true or not? Is that one of those myths that we are saying?
I would say, fundamentally no, but of course you train yourself doing what you're doing. So if you're engaged in, puzzling or, Scrabble, computer games, there are like computer games that require no brain power and there are really, really hard ones. So it depends very much on which task you're talking about.
What about the multitasking, and if we think of the communication tools like being, on Facebook and
well, I'm not an
WhatsApp
expert,
all
but
the time?
I have read studies claiming that people who are good at multitasking, they don't really multitask. They sort of do one thing and then they switch to another thing and then they switch back quickly. So this is more or less how people work.
Okay, because I'm hearing I will also mention just quickly the Paul Kirsener. He has, from the Open University of the Netherlands, he's looking into that and he's saying well, nobody's actually multitasking.
Yeah, that's what I was hinting at, yeah.
Okay.
If I sing when I dance.
Okay, so then since it's kind of almost Christmas, so I can give you a final question. Like, if you were to wish something when it comes to school and digital competence, programming, computational thinking, technology, and so on, what would it be? Like, if you could get something or change something, what would that be? It's almost as silent as
Are
when
you
we came
asking
before.
all of us, or?
Yes. Everyone get a wish.
Well, I'm thinking about the teachers out there who are suddenly supposed to teach programming or whatever, and I guess I would hope that there will be some good way to prepare them so they can manage this sudden task that is put upon their shoulders.
Competence development, yes.
And I think, as you said, Fredrik, before, that these kind of meetings are very contributional, and I hope that Trippel Helix, I would like to thank you for the first, and hope that we could arrange, that you can arrange similar meetings in the coming future.
I was hoping someone else would do it.
Yeah, but it's just something like to keep the discussion going. That's the aim of the project, I know, but I think that's been very fruitful along the way.
Continued collaboration.
Yeah.
Good. Thank you.
On this level. Yeah.
Well, and my wish, I think we all had our points in our presentations, but if I want to wish, so I would wish that we continue to be more critical about what digital competence is about, and that we use the concepts in the right way. I think using the concept of critical thinking and programming are different things for me, for instance. And I have several wishes, actually. So I also wish that we acknowledge more the work of our students and what they express in their work in school, and develop teaching around that. That's my wish.
So include the pupils more in the teaching, which very good. Thank you.
Well, I have already stated my wish, but I really think a lot of money into a project that try to expand the boundaries of how software, what they can do, because we have created the software, and the teachers have. I want the teachers to be agencies in what a software can do. That would be a really good Christmas present for a project for this, and a lot of money.
A lot of money. I'm sure. So, well, according to Matti, if and machine learning really revolutionized, maybe you can just generate it. You just have to click the right buttons. Oh, well. So, yeah, I think it definitely more inclusive software development, probably a good, and to have more flexible software is very useful. Okay. Thank you very much, all of you.